just bring this back here. All right, thank you everybody for participating in this webinar to the experience simulation, basically to see what's new in 2022x. So today, first of all, for those of you who don't know me, my name is Ricardo Magalhães. I'm a senior application engineer here at Optimec. I've been in the Dassault ecosystem for around 10 years now. So I worked 5 years at Dassault system before coming to Optimec, and at Optimec I've been another 5 years now. So essentially I have an expertise in CAD design, FEA simulation, and process optimization or design optimization. So I've been helping customers either with their projects or ramp up their skills in the applications in the simulation roles we're going to present today. So the contents for the presentation today, so we'll go over the portfolio to see essentially what's available on the 3DEXPERIENCE platform in terms of simulation roles. I'll then talk about a little bit about the new unified license model. So they changed the licensing model. There's also a new simulation service from Dassault System. So a new infrastructure will cover that also. I'll jump into the all physics analyst simulation role, which can be quite interesting for you, some of you guys. And next we'll be covering essentially on the structural simulation side of the roles, the general enhancements, and also some specific enhancements for two specific roles, which are structural performance engineer and structural mechanics engineer. All right, so in terms of the portfolios, just wanted to show you a quick overview of all the offering in terms of simulation roles. So as you can see, there's a lot of simulation roles available. There's new ones you can see highlighted in blue, which are durability performance engineer, or those are roles for fatigue analysis. So I know some of you might be interested in doing some fatigue inside the 3DEXPERIENCE platform. So these are the roles that you will be looking at. There's also a new electromagnetic engineer role that was added. So these new roles were added in 21x FD04. So it's been a while they were introduced. But the idea here is if you have any questions or you see any type of in your role that might be interested into you, feel free to reach out. We'll be glad to present you the role and do some demonstration about any of these roles. So first subject and topic is the new unified license model. So if you've been using 3DEXPERIENCE in the past, it could get quite complicated if you wanted to get some extra compute capabilities. So you would need some tokens or either credits. So depending on the discipline you were in, so if it could be structure, fluid, or multi-body dynamics, it had some specific tokens or credits. So it wasn't very easy to predict or select the right type of tokens or credits. So what they did, so they unified the solution for the licensing model. So now any type of role that you have in simulation, you're going to use essentially the same unit tokens and credits. So no more specific tokens or credits for some application. They're all the same. So what this does is offers us flexible and scalable compute capability when you get the simulation roles in the 3DEXPERIENCE. So if you see at the typical simulation workload and organizations, there's three types of solutions. So there's the embedded compute that comes with the roles. So those are there to cover an essential base level of compute capability. If you have, after a predictable and consistent usage of simulation in terms of workload, you can get some tokens. So this is there to provide fixed budget. You know it's a yearly basis, and you can predict how much you're going to use in terms of simulation. And then there's the flexible part, which is the sim unit credits, which is there to cover essentially the unpredictable or the bursts in simulation workload. So these are the three solutions to cover all your compute needs. So compared to the traditional compute licensing model, this new model is easier to understand, to use, to manage. There's a single pool of tokens or credits across all disciplines. So again, if you have two roles, fluid dynamics or in structural, the same tokens can be used in either roles. And there wasn't really presented here, but there's an incentive here to run more simulation. So when you start doing design exploration with the 3DEXPERIENCE platform, it's on specific roles, you're going to see there's an algorithm behind that. The more you're going to run on simulations, the less it's going to cost you to run individual per simulation, basically. So any questions on this section of the unified license model?
It seems like there is no question yet, but feel free people to ask it either in the Q&A section next to the chat or directly in the chat.
Perfect. I just went back to my other screen to see if there's any questions. All right. So next session about the new cloud compute service. So essentially, Dassault System introduced a new compute service a little bit more than a year ago, around summer last year. So essentially, this is a new infrastructure. They call it the grid. But what it means for the user is that you can have access to more powerful CPUs, GPUs, and you can run on more core counts now. So we can go up to 1,000 cores in some specific roles. And on the post-processing side, there's also a new improved algorithm in terms of managing the data from your results. So what you should see in terms of experience is that when you want to see your results, it should be faster to have the first animation, the first counterplots of your simulation results. And another new amazing feature is that you're going to be able to free some local computing resources that I'm going to talk in the next slide. So in summary, better HPC performance, you're going to get your results faster, and you should free up some HPC local computing resource that you might have. Here I wanted to show you essentially depending on which simulation role you have. This is a table that I took from another presentation, but you see here the trigram. So if I take, for example, FMK, which is fluid dynamic analysis role, it comes with embedded compute, 16-core embedded compute. And what's the new amazing thing is that you can run your simulations on the cloud, and you can use 16 cores free of charge. So this is basically giving you like a HPC worth of $20,000 for free with your simulation role. So you should take advantage of this. This is really amazing. So it's going to be able to free up your local resources, and you're going to do more simulation if you want so. So also I showed you the trigrams for the sim unit tokens and credits if you're interested in getting those. All right, so in terms of applications, what's new for the structure side? There's a new parametric design study, which all of these new applications I'm going to talk about are all running on the new compute services, so the new grid. And the first one here is a parametric design study, which is an amazing application. If you haven't played with it, I strongly encourage you to go and have a look at it. It's available in the structural analysis engineer, structural mechanics engineer, and fluid dynamics engineer. Essentially, it's, well, the name says, pretty much tells everything. Parametric design study allows you to essentially optimize with some parameters of your design, so of your cloud model, for a specific goal. So it can be to attain a specific stress level, optimize mass, etc. So this essentially is an application that usually these features essentially in this application are taken from another role, which is multidisciplinary optimization engineer, which is a process automation tool. So I strongly encourage you to look at it. It's amazing. You can run up to 4 concurrent simulations on the cloud if you have the sim unit tokens. So great application. The next up is the durability applications. So if you want to do some fatigue, it comes with 8 cores embedded compute, and you can run up to 36 cores on the cloud with sim units again. And the GDE function-driven generative designer, which is topology optimization software, comes with 4 cores embedded in up to 36 if you run on the cloud. Sorry. On the fluid side, the FMK, like I said, there's 16 core embedded compute, and you can go up to 144 cores if you have sim units on the cloud. There's a GDF, which is essentially like the GDE role for structure optimization, but this one is flow-driven generative designer, so you can optimize the flow. So you define your design space and establish your boundary conditions and let the software compute the best flow. And there's also, this is new for 22x, the power flow powered by solution and next flow powered by solution that can now use the new compute service from the SO. And as you can see, you can go up to 1,000 core on the power flow side. And if you guys don't know what's powered by basically is you still need the traditional software power flow, but it's kind of integrated with the 3DEXPERIENCE to take care of the data, and now you can run the simulations on the cloud. And then the last one is the plastic injection engineer. Sorry. Comes with 8 core embedded compute and up to 16 cores if you have sim units. All right. So a quick note on the all physics analysis role, and this is in reference to these new powered by solutions, PowerFlow and Xflow. So the all physics analysis role is basically an interface, web interface. It's a role basically, but you can access it on the 3DEXPERIENCE web base via a browser, and it allows you to run different simulations. So if you're an Abacus CAE user, you can basically import your input file. You're gonna be able to access your content, run the simulations, access your typical DAT files, STA file, message file while the simulation is running. And then if you want to view the results, you can either view them online with a specific web app, or you can download the results and post-process them traditionally as you used to do. So there's different type of connectors in this application. There's connectors for Abacus CAE, CST, PowerFlow, Xflow, SynPack, and Wave6. These are all powered by solutions. One last thing on this application for 22x, the PowerFlow and Xflow, which are CFD solutions, you can post-process the results directly on the cloud. So there's no need to download your results that can be quite large. So if you want to use the cloud DS Cloud service to post-process, you can do it. There's an interface, and you can post-process the results there and view all your simulation results, basically. Any questions regarding this section? Sorry.
Seems like there's a question.
There's no questions? There is?
Yep.
Okay. All right.
No.
I can't see the other screen, that's why. All right. So on the structural simulation rules side, I'm going to cover essentially in this section the general enhancements that were introduced. There's a lot of enhancements that I will not cover here, but I took essentially the ones that I think are most are the ones that are going to more impact you the more when you're going to create your models. So the first one is on the modeling and meshing enhancement side for the welds. And here I have a quick video for each new functionality. So the first one is a new check and fix tool for compatible line fastener connections. So this should improve dramatically the meshing success rate. So I'll just play the video and we'll see what it's about. So in a typical model, we always add these shell parts, which we need to do some line fasteners between them. And the struggle here is always the challenge to create a line fastener that would essentially match both interfaces of the parts we're trying to connect. So there's a new check tool on the connection manager that is going to open right here. There's a new hidden column that you can show. Here is just going to filter out the line fasteners. And you can add this, there's a seeding column, and you can see where the issues you have in your part, which line fastener has issues with seeding. And here there's a new seeding resolution that should improve essentially the mesh to basically create your line fasteners afterward. So this is a great new tool. As you can see, your line fastener is complete. All right. So the next one is about lap joints. There's a support for lap joints when you're trying to create, again, the line fasteners. Again, this should improve the time effort you're going to put into creating those. So I have another quick video here showing this feature. This is the typical subframe of automotive. There's a lot of welds in these parts, and when you try to create those line fasteners, it can be, again, really challenging. So here you can see we're going to use here a line as a support for creating the line fastener, and there's a projection option called lap joint that will create essentially the line fastener. There's also a new options in the fillet in which you can simulate a real weld. Basically, you can add a layer of line fastener, as you can see, and it would essentially simulate a typical weld. So again, great new feature. Next one, and this is a big one for us. This is essentially an issue that we spoke to last year to Dassault System. And what's nice is to see that the issues from the users, Dassault System takes the time to listen to them and try to fix them and future releases. So this was an issue for non-circular holes using the virtual bolt tool. So if this virtual bolt is essentially it creates a connector between two parts, and it would work essentially very well for circular holes, but any non-circular holes like oblong, squared, rectangle, elliptical, we couldn't select them. We couldn't do those virtual bolt connections. So now this functionality is available. It can go through different type of holes. If you have a circular hole and a non-circular one, it'll still do the connection. And to create those, to select the support, only one edge is now sufficient. You don't need to select the whole contour of your hole. And once it's going to create the connection, it's going to connect the connector beam representing the shank of your virtual bolt to be at the center of the hole and normal to essentially your surface. So great improvement for this side of the virtual bolt. So the next one would be for virtual bolt detection tool. On top of adding the non-circular holes capability, we also have a possibility to select solid meshes or solid parts. So if you use this tool before, you know that it will work very well for shell mesh. So it will recognize for, again, circular holes and shell mesh, but now it's extended to non-circular, and also to solid parts. So if you have a connection between a shell and a solid mesh, it will still recognize there's a hole there and create a virtual hole. Other new features is on the results side. So when you get the results from the search, there's all new information that is quite useful. And when you try to see what type of holes are considered in a specific virtual bolt. So if you have different type of connections for different type of holes, you can filter them out, apply a specific connection type, and go back, do a search again, and reselect other type of holes for another type of connection. So this is this new filter option is quite useful to create the virtual bolts. On this slide, we talk about the point fasteners on flanges. So this is a new feature that is available, a new method to create the point fasteners. If you've done point fastener in the past, again, you know that you need a support geometry, and it's not annoying, but it can take some time to create those points and line fasteners when you want to do the point fasteners. So for flanges, there's an option now to create those point fasteners without having a geometric point or line geometry on the CAD side. So you can just select the surface, define your distribution and clearance along the flange, and it will create essentially all your point fasteners along the flange. So again, this will save some time and on creating those point fasteners on flanges. All right. So now we're going to talk about sub-modeling and the automation, the new generative modeling tool for sub-modeling simulation. So this is quite useful if you want to study more locally the stress of your assembly or your part. So in the 3DEXPERIENCE, there's a new tool that allows you to quickly create those sub-models and study them quite efficiently. So here you have a typical simulation of a vessel. We see that we have 348 on the edges here of the outlet or inlet. And we want to basically create a sub-model of that region to see if in reality we have that much stress on that region. So we're basically, I'll just stop here quickly and go back. We're using this application called Model Assembly Design and the automated FEM tool, which allows you to create a sub-model on basically what this does is creates a separate FEMREP with this new region that you can use in another simulation. So here you can see with a box trap region, you can define the section you want to study, and you're going to be able to directly define the mesh properties, the mesh size, the element type or order, and basically we'll create that sub-model. And what's nice is that you can go back to your CAD geometry and add those features that were defeatured. So here we're going to add a fillet that was removed in the modeling process. So we're going to put back the radius and the fillet, sorry. And then we're going to create a new use case, simulation use case that in the simulation side, and there's a specific, goes really fast here, but there's a specific sub-model analysis case, and you select the new FEMREP and rerun the simulation. And you can see there's the stress went down quite a bit in that region. So again, a very nice feature for to study stress more locally and validate your designs or parts. All right, next is about, it's still in the same application, and there's another feature called preload FEM. This essentially the possibility to reuse simulation results in a subsequent simulation. So these typical type of simulation that you do is multiple drop tests, or again, sprint back analysis. So if you want to include manufacturing effects or preloads in your assembly or parts, this is the tool, again, that you should be using. And again, I have a quick video showing you how it's done in a very fast pace. But here we have the deformation of a simple disc shape sheet metal. And this is defined in realized in an explicit dynamic step. And then we're going to create a new FM rep with this final state of the simulation and study the spring back of that of the part of this disk. So again, we go back to the simulation, the model assembly design app. We use the preload option in the auto-landed FEM tool. Again, we're going to be able to select the analysis, the last increment that going to be imported as a mesh. And we'll be able to create a new analysis, a new mechanical scenario. So essentially a new simulation, static simulation to essentially study the spring back of the part. So here we're just defining the typical boundary conditions and the step definition. And we rerun this new analysis with the results. All right. So next slide is, these are minor modifications, but I found them very useful, and it kind of changes all the experience using the software. Modeling and meshing on when you create a simulation, there's this new in the simulation initialization menu where basically you just define the basic stuff. So the title, the type of analysis, or in the FM rep you're going to use. So this, if this menu wasn't available, you had to go through all the menus to essentially define those or modify those settings. So this is a nice feature that was added. And one of the great things they did is the modeling and meshing tools are now in the same applications. So there's no more need to switch between the modeling app and the meshing app, because it was just unnecessary, to be honest. So there's going to be a new tab in the structural model creation application that's going to be available to define essentially all your meshing needs. So you see the mesh, and all the tools are now available to. Just going to quickly forward. So all the meshing tools are now integrated in the model application. All right, so this slide is about general context for all users. So for those of you who are not familiar with general context, I think the crowd knows, you guys know pretty much what's general contact. But essentially, it's a contact algorithm that's the flagship of Simulia solutions. So what they did is they extended this feature, which is essentially basically for expert users, but they extended to designers or like people who don't have that FE experience when creating some analysis. And general contact, they added some nice features to basically allow an easier setup of the general contact. So general contact is contact defined to all the parts in your model. And there's also an option here for small sliding. So essentially in lower here, you can see that we have an image of the structural design role, which is an entry-level simulation role. And typically you do linear analysis with this role. And when you do linear analysis, you don't want the full contact to be there. You can use small sliding, which is usually the contact that would be used in those type of analysis. There's also default contact initialization there, assignment when it creates, when it's used, and essentially it allows you to have a better convergence in your simulation. Saying that is not saying that you can't have access to the expert level. You have access to essentially, if you want to do more complex thing, or if you want to define only contact between two specific parts in your model, you can still do that inside the general contact. So this is a new great features that was added in all simulation structural roles. The next feature is on the results analysis side. This is a feature, if you use Advocacy, you're very familiar with this. So this is the ability to essentially view the results while the simulation is running. This was a feature that wasn't available in the 3DEXPERIENCE platform. So they added this feature basically to see how your model behaves, if your model behaves as expected as the simulation progresses. So once you have a step that is written to the simulation results file, you can go in and view the results. So this again is a nice feature that was added. On the results analysis side, there's new filters. So the option to add filters to your history output results. So this will essentially attenuate high frequency solution noise. So typically those filters are used for explicit analysis, and without those filters, it's quite or very difficult to analyze or take any decisions from those results because there's too much noise in them. So this is now available. You can define it when you define your history outputs, or you can also use it later when you're doing your post-processing. Another feature is the virtual strain gauge tool. So essentially this is a new sensor that is available. So the strain gauge sensor is there to essentially validate your numerical simulation with the physical experiment you're going to do, and also to determine where the best location for the next physical test if you're expecting to do one. So that was it for all the enhancements that we'll cover today. What's next for the next release, essentially? So essentially these are subject to change. But essentially what's coming is the new keyword editor tool. So if you're an advanced user, I'm sure you're excited about this new feature. So you're going to be able to add keywords to your models in the 3DEXPERIENCE simulation roles. On the scenario side is going to be support for fully coupled temperature displacement procedures. So we'll give you more possibilities for simulation. And on the post-processing side, there's a new camera feature that basically allows you to track any particular node or part during like an animation or anything. So this is kind of a nice feature to have when you present the results. So that's it for this section. Is there any questions regarding?
Yes, there are plenty in the chat. Do you want me to read them, or do you want to go read them by yourself?
I'll go myself and read them. Okay. Chat. Okay, I'll just start with the last one and go up. So it's going to be easier. So the first question from Maxime Rivard: does the result visualization also unlock the rest of the software with 21x? When the simulation ran, it bricked the entire software, so nothing else could be done besides wait for resolution. Does this results which also unlock the rest of the software? What I'm not sure I understand. What do you mean by unlock the rest of the software? Can you give access to Maxim? Can Maxim speak, or we just gonna? Yeah.
Maxim, I'm gonna open your. I'm gonna unmute your audio, if you don't mind.
Yeah, I think my question was answered by another user. Mostly the options I ran the simulation, I think. But yeah, when you ran the simulation with the interactive mode, the pop-up box that lists the progress of your simulation, you cannot close it or change anything else. Let's say work on another assembly or something.
I think that's still the case. So essentially, when you run it in interactive mode, you still have to keep that window open for the simulation to run. If you don't want to have it in interactive mode, you should run it in non-interactive. So you can close the window and keep doing the work on the platform. Does that answer the question? All right. So I'll just go up. Results visualization during execution. Is it possible to see mid-step results when we only ask for one result, last frame of step? The results going to be able to see are the ones that are going to be written to the simulation file. So in mid-step, if you didn't ask any step for that mid-step, you're not going to see the results, basically. I hope it answers your question. Same question about point fasteners or flange. Is it available now? Does AutoSAR modeling work for shell models? So the point fastener should be available now. So if you don't see it, I'll look into it, but it's a feature that was added in the recent release. And for the AutoSAR modeling work for shell models, I'll have to go back and get back to you on this one. I'll just write a note here. All right, for you. If you can take that, be useful. Okay, the next one is virtual bolt for non-circular holes live now on 22x. It should be. So all of these features that I present today, they should be all working. This was presented a while back, so these are all features that should be available. If you don't see them, get back to me. I'll see what's going on. Another question about the line fastener tool. Does it work with multi-level mesh? In the example, all meshes are in the root assembly. Again, I'll have to get back to you. In theory, it should be working for multi-level mesh. So I guess multi-level is a different mesh depending position indifferently in your structure. So it should be working. So I'll get back to you on this one too. All right, I think we cover. I think there was another one in the end. Running the local non-interactive mode, it's very unstable. Too many crashes or simulation drop. Sorry. In 22x. So about the crashes, I'll have to see. It can be a use by case situation. Could get in contact and see what's going on with those crashes. We'll come get some traces and do a service request. This is for Yann Roger. So don't hesitate to reach out if you have a lot of these crashes. So we'll try to figure out what's going on. Is there other ones? Running cloud works fine as well. Okay. Does the keyword editor allows for material modeling modeled unsupported by the material calibrations in apps in 3DX, but already supported by Abacus CAE? I'll have to get more information on this one, Maxim. I don't know yet what's going to be able. I know the feature is coming, but I don't know the extent of the implementation they're going to do. So I think that's pretty much all the questions. Is there anything I missed?
I think you're all good.
Okay, so I'll go back to the presentation. All right, so the next section is about some specific roles so that you guys might have. Sorry. So the first one is the structural performance engineer. So I'll just cover in terms of functional value and experience, user experience value, what they added, new functionalities that are now available. So we spoke about the general contact that is now available. This is a feature that wasn't available before in SFO. So the small sliding in general contact is now an option when you're going to define your contact definition in general contact. On the scenario side, there's going to be support now for hydrostatic pressure. So again, this is something that wasn't available before. You can now apply hydrostatic pressure on your containers or any part of your model. You're going to see new features on the connection sides. So you're going to see that there's on the coupling type, there's going to be structural distributing option now. On the connector behavior, there's going to be added rigid option. So there's a few improvements on that side. There's a little bit more options in your definition of connectors and connections. There's also an option to save your connection templates. So this is very useful if you want to reuse your connections eventually, or even to standardize the connections you guys do in your models. So this is a feature to essentially save them in the database and reuse them later. All right, so post-processing, we spoke about the virtual storing gauge. So this is the same tool I mentioned in the general enhancements. On the user experience value side, when you guys are going to create your fasteners, so you can use the fastener creation automation tool. You can now use the data coming directly from CUTIA fastening app. So if you guys have that application, you can now import that data directly to create your fasteners. So that's a new feature that was implemented. And the last one is about the post-processing. There's a new, essentially, variable of contour transparency. This is a nice feature to essentially have a better view of your results. So as you activate the option, you essentially can control the transparency on your contour plot. So you can isolate your regions which have a lot of stress, essentially. It's a nice feature. On the structural mechanics engineer side, on the scenario side, there's a new risk step that is now available. So risk steps are used to essentially study a very unpredictable or unstable buckling or collapse of a structure. So this is now a step that is available if you want to create those types of analysis. And there's a full support for a couple piezoelectric analysis. So if you want to do those. And on the user experience value, the material definition menu, it was added here, but it's more of a general enhancement. I guess it was enhanced while they did this structural mechanics engineer role improvement. So essentially, what you should see is just like in terms of user interface, it got improved. There's scrolling features, etc. So essentially, dealing with the material definition menu should be easier to apply your materials. Next is on the scenario side, there's an on-the-fly access system creation. So essentially, we all deal with having a need to have an axis system to define the direction of a force or of anything. So we had to go back in the CAD model, create that axis system, and go back in your scenario application. So now there's no need for that anymore. You can just basically create it on the fly and go on with your scenario model. The last one is very useful, I think, is on the post-processing side. You can save your contour plots and sensors and all your, essentially your view of your results into a template. And you can reuse it afterwards in another analysis if you do a lot of the same analysis, type of analysis, and you always want to look at the same results. You can save those templates and reuse them eventually. So this was the last feature for the structural mechanics engineer that was added. Any questions on that section? Just go back to the chat. All right, so the last one from Yann Roger, results template, is it only a SSU feature or is it available in SFO? I'll have to look into it, but I suspect it should be available on SFO also. So anything that has to do with templates, I think they kind of generalize the options for everybody. But I'll get back to you on that feature for SFO. From Benjamin Becklink, if keywords exist for Abacus Solver, they should be supported by Keywords Editor. Otherwise, you should manually. Okay, this I think it's for answering a question. Yeah, that was for a previous question. Sorry. So, is there any more questions about this last section? No. All right, so I want to thank you for participating in this presentation. I hope you learned something, and don't hesitate to visit our website. And if you need any information, feel free to reach me or any Optimic person. Will be glad to help you with your needs.